This is an experiment of a full wave bridge rectifier circuit using rectifier IC. And I have used the rectifier IC. Number is W10M. It has got plus and minus terminal on this side and this side, opposite to diagonal on this side and this side. And other two terminals, we are going to connect it to the transformer. The plus terminal, this leg, you should connect to 1 kilo ohm resistor, and other minus terminal connected to other terminal on the breadboard. That is, resistor is connected on the breadboard, one terminal to plus and other terminal to minus. And the other two diagonal terminals are connected to the center tap transformer, one to the first end and the second one. You connect to the middle one. Here in diagram, I have shown the first and last, but first one you connect to one terminal and the middle one you connect here. So if you connect middle one, it will be, if it is 12 volts transformer, we will get 12 volts here. If you connect first and last, it becomes 24 volts. So don't use that. First and the middle one you are going to connect it. So this is the input waveform we get across the secondary of the transformer. When we measure voltage between the secondary of the transformer windings, I'll get the sinusoidal input waveform. When I measure the voltage across the resistor using CRO probe, CRO positive terminal to one end of resistor and negative terminal to other end of resistor, I'll get a pulsating DC. So the aim of the experiment is to construct full wave bridge rectifier circuit using rectifier IC to convert AC voltage into DC voltage and observe the rectified output waveform. And apparatus required are bridge rectifier IC, step down transformer, either 12012 transformer use or 909 you can use, or 606 also you can use. Resistor 1 kilo ohm, 1 watt resistor, connecting wires, breadboard and oscilloscope. So connection, as I explained just now, you make the connection and compare the waveform with the theoretical waveform. These are the theoretical waveforms. So you should get waveform in this manner. Now I'll show you how to do the experiment. This is a rectifier circuit using rectifier IC. The IC number is W10M. It has got two terminals, plus and minus. Plus terminal is connected to resistor one end. Minus terminal is connected to resistor another end. The other two terminals are connected to transformer secondary winding, and we'll connect the CRO across resistor to check the pulsating DC output waveform. This is rectifier IC W10M, plus and minus terminal, and other two terminals for transformer. We need a resistor, so connecting 1 kilo ohm resistor on the breadboard, and the plus terminal of rectifier IC is connected to one end of resistor. Plus terminal is connected to one end of resistor, and minus terminal is connected to another terminal of resistor, and another two terminals are connected to transformer secondary winding. Transformer secondary windings. Now turn on CRO. Keep all the positions on the extreme left, all these in outer direction, and we are using channel 1. Connect CRO across the secondary of the transformer. So CRO is connected to the two terminals of the secondary winding. Now we will check the waveform. This is the input sinusoidal waveform which we are getting it from the secondary winding of the transformer. Connect the terminals across the CRO resistor. Connect the CRO terminals across the resistor. We will check the waveform now. This is the output waveform of the bridge rectifier using the rectifier IC. If we connect the CRO terminals in the wrong direction, positive in place of negative or negative in place of positive, what type of waveform I will get, I will show you. See, this is wrong waveform we are getting in the CRO. This is not the rectified DC output. we should get the waveform. This is the correct rectifier output waveform, pulsating DC.